All right, so we're going to solve equilibrium constant expressions here. This is KEQ. There's a video on my class website that another teacher made about writing KEQ that is very good and pretty short. But basically what we're doing here is we have our products over our reactants raised to the powers of their coefficients. So I'm going to go ahead and just write KEQ over here. And that is the concentration of NO2 raised to the second power, which is this number right here. That's where I got it. Divided by the concentration of N2O4. And because there's no coefficient, we could raise it to the first power, but we don't technically have to because anything to the first power is just itself. Now, this formula that we've just written is really just like we wrote X over Y or something like that, because I give you these in the formula or in the problem up here. You can plug these numbers in to solve for KC because KC and KEQ are almost the same thing. KEQ is the formula, KC is a number. So I'm going to come down here and I'm going to go ahead and just plug those numbers in. NO2 is 0.03 and that was squared. So we're going to put that like that. Divided by 0.0045. And then I'm just going to simplify, and that's all we're going to do here. So I'm going to go ahead, I'm going to take 0.03 and square it, and I'm going to get 0.0009, and that's divided by 0.0045. And once I do that in my calculator, I'm going to get 0.2. There's no units on this. That's it. That's the end. That's the answer right there, 0.2. And that's it. That's all that there is to this. So I'm going to do another example here for you guys. Let's look at this one right here. This one says if carbon monoxide is 2 molar and carbon dioxide is 1.25 molar at equilibrium, what's Kc? So again, we start off by writing our KEQ, our equilibrium constant expression. Notice that this is a solid and so is this. We're not going to use those in our equilibrium constant expression. We don't need them. Another good hint to that is that I don't give you concentrations for them in the problem up here. But we're going to go ahead. Here's KEQ, the concentration of our product, carbon dioxide, squared over the concentration of carbon monoxide, squared, right there, just like that. That's KEQ. All right, now we're going to plug everything in and solve. So I have that CO2 is 1.25, and that's squared, and CO is 2 squared. And we can go ahead and simplify that out. That will be, bottom will be 4, and 1.25 squared is 1.5625. And when we do that math, our answer here is 0.39. And I'm rounding here to 2 decimal places. That's how we solve that. On this last one here, I want to make a note that you'll use everything in this problem. Nothing needs to get canceled because they're all gases. But on KEQ, we multiply. We do not add. So our products are going on top. That's SO3, and that is going to be squared. And on the bottom are our reactants, which are SO2 squared and oxygen, O2. Notice that these two numbers right here are multiplied, not added together, okay? Multiplied together. So I'm going to go ahead and solve this one really fast. I'll just jump to the end of the problem where you can see my work and my answer. My answer here is either 1.32 times 10 to the negative third or 0.0013, which these are the same number right here. One is just in scientific notation. And that's how you solve equilibrium constant expressions.